Very good afternoon, everyone. It's my pleasure to welcome all of you to the first webinar of the series, Data Analysis Made Easy with Jamovi Software, hosted by the Department of Community and Family Medicine, AIIMS Patna, in collaboration with Merit India and Planet. Myself, Dr. Venkatesh Karthikeyan, Community and Family Medicine Postgraduate Resident from AIIMS Patna, and I'll be the moderator for today's event. I'm thrilled to see such a fantastic response for this webinar with over 2,200 participants registered from different corners of the world. As we all know, data analysis has become an increasingly important tool in the healthcare industry, allowing healthcare workers and doctors to analyze and interpret vast amount of data to make informed decisions and improve the patient outcomes. This webinar series aims to provide insight into data analytics and its application in the healthcare. For this, I would like to welcome Dr. Pragya Kumar ma'am, Additional Professor of the Department of Community and Family Medicine, AIIMS Patna, and the Registrar of our institute. Ma'am has over 50 research publications to her credit and has trained over 5,000 researchers across the globe through her workshops and webinars. With this short introduction, I would like to welcome ma'am. Over to you, ma'am.
Thank you, Karthikeyan. And without further delay, I will start this session. And this session is all about Jamovi. And we'll see how this Jamovi has made all of us life so easy, all the students and researcher, and that we'll see soon. So today's topic is data analysis, and today's special emphasis is on the descriptive statistics. So this is the data, and we all collect data, whether it is in a thesis, MD thesis, or a PhD thesis, or we are doing a short project. But unless and until we carry some information or we make some information so that the interpretation is easy, this raw data does not carry any meaning. So we need to summarize it. So now, how to summarize the data? So the first and very important thing is the descriptive statistics. So I'll give a short overview of the descriptive statistics. So basically, descriptive statistics you will see everywhere. The data analysis starts with the descriptive statistics because it summarizes the data. We take the sample out of a population and then you summarize your sample. So when you summarize your sample data in a meaningful way, that's known as the descriptive statistics. So it is also known as the summary statistics. And it summarizes, that's why it is known as the summary statistics, because it summarizes your data, the characteristics of the participants. So generally it is of 4 types. And what are those 4 types we'll see? It has got no uncertainties because descriptive statistics, you are not projecting anything. So descriptive statistics has got no uncertainty. And we'll see how it is different from the inferential statistics. And the limitation is because you cannot interpret in context of population. So if you are giving the descriptive statistics, you cannot say that, that value, how that value will go into the population. So it is a summary of only those individuals who are there in your sample. So I said that there are basically 4 major types of descriptive statistics. So the first is the measure of frequency. And the measure of frequency, we express it in the form of a count and percentage. The second is the measure of central tendency, and we all know that mean and median are the measure of central tendency. Then there is a measure of dispersion and the standard deviation interquartile range, and the range is basically the measure of dispersion or the variability. And then there are measures of position. So percentile, quartile, decile, centile, all these are the measure of position. When we see the 5th, 95th, 50th, and the 50th position is the median. We'll see it. So descriptive statistics, like we discussed, that there is no uncertainty with the descriptive statistics because we only describe the sample. We don't want to infer about the population, and we are not doing any hypothesis testing. So hypothesis, as we go ahead with the sessions, we learn about the null and alternate hypothesis, and all the time we form 2 types of hypothesis, and we accept or fail to reject the one type of hypothesis. So this is the hypothesis testing. In descriptive statistics, we don't test any hypothesis. That's why you will not see any hypothesis testing today's session. Coming to the inferential statistics, what is inferential statistics? So basically, in inferential statistics, you infer about the population. That's how its name is, inferential. So you want to infer about the population from the data set which we have withdrawn. And that's why there is some amount of uncertainty which exists with inferential statistics. And in this case, we form a null and alternate hypothesis so that we can infer about the population. So the strength of this type of analysis is that we can estimate the population parameter. But again, like, there is no uncertainty with the descriptive, but some amount of uncertainty always exists with the inferential statistics. So today's session is whole about the descriptive, so there won't be any uncertainty. But as we'll move ahead with the webinar, you will see every time we will do the inferential statistics so that you can infer about the population. So in this case, although we describe about the sample, but since we always express the result with the confidence interval, so we try to infer about the population and we do the hypothesis testing as well. So coming to the descriptive statistics, likewise, I said that there are 4 types of descriptive statistics: counts and percentages, which is the frequency table. Then the second is your central tendency, which is the mean and median. Then the third is your variability or the dispersion, where we see the various type of standard deviation, standard error, etc. And then there are positions like centile. So coming to the descriptive statistics frequency. Now this is the first thing which we see in our descriptive analysis. Now frequency, we have got 2 basic measure of frequency. First is we make a frequency table. So we make a group frequency table where we have got some class interval. Like for age, we generally define age with a class interval of, probably depends on the highest and the lowest level, whether we'll take 5-year, 10-year, or do we have some biological criteria to take that age? Like in case of adolescent, already it has been defined like early, mid, and late adolescent. If you go with the non-communicable diseases, the WHO has given an age criteria that how you have to take the class interval of age. So if there are some pre-defined criteria, you should go with that criteria. Otherwise, it should be biologically plausible. If that criteria is not available, then you should take a equal class interval where the width of the class interval should be same. And the graphical presentation of the frequency is by the bar graph. And there are various type of bar graph. And we'll see in Jamovi how to plot the bar graph. So let's see various type of descriptive statistics table. So like I said, that your data analysis starts with your descriptive statistics. So in this case, this is one example of an overall frequency table. So you can see here that this one, there are 2 ways to express a frequency table. In this case, you can see the categories and the number and percentages. So these are the various categories, and this is the frequency of the categories. So it is the count as well as the percentages. So the author has given both together. So this is one way of representation of your frequency table. Another way is, you can see here the author has written, and this is a study of prevalence of anemia and the socio-demographic factors associated with the anemia among pregnant women in Aurangabad city. And you can see here that the author has given the age and the class interval which he has taken, it is 5 years. So you can see less than 20, 20 to 24, 25 to 29. And again, religion, socioeconomic class, etc. He has given this number and percentages in a separate column. So both can be done. It is up to you. Again, descriptive, this was a descriptive simple table. Then there's a descriptive cross table. So you can see in this case, this was a study. The title of this study is, Does Smoke from a Biomass Fuel Contribute to the Anemia in Pregnant Women in Nagpur, India? It is a cross-sectional study. And you can see here that education, the exposure to household tobacco smoke, the parity, and then trimester, all these have a categorical variable, categories are there. And the author has given the comparison, like between the clean fuel user and the biomass fuel user. So there are 2 categories. So it is a class, it is a cross tab. So cross tab between the clean fuel user and the biomass fuel user, and the author has given the frequency table of both these 2 together. So you can do, you can choose either way. You can give the frequency table across, that is a cross tab, or you can choose to give a simple description of a frequency table like we have seen in the previous, this one, like this. So now coming to this is again one article where you can see this is another way of representation when your categorical variable is mostly in yes and no, or something as a natural variable like female gender you can see here. So this was the article, the title of this article is the effect of early treatment with ivermectin among patients with COVID-19. This was published in the New England Journal of Medicine, and here you can see in the descriptive, the author has given only female sex, the number and percentages. So it is implied that the rest of the, like if 56.4% is women, then the rest 44% or the 43.6% will be men. So if your table is becoming very huge and it is taking a lot of space, and if your variable are like yes and no, then you can choose only to give yes as a percentages, and then maybe the other part it is understood that the other part is existing. So this is another way. So we have seen there are three ways of representation of a frequency table. First, you can give count and percentages in a single column, or you can separate these two columns, or you can have a cross tab, or fourth one, you can give only the percentages of a one category where the other is implied in. But this can be done only if you have got two categories. You cannot do this if you have got more than two categories. So now there are now you have to post your response for the questions asked in the next slide. So this is one you can see here. One table is there, and this is the demographic characteristics of a pregnant woman. And the age group are like 20, 22, 24, 25 to 29. And the question is, can any statistical software directly generate a table like this? So please type your response in the chat box. So I can maybe. So the answer would be, can I have a look at the responses? Okay, so answer would be no. And then how many single tables are generated in this joint table? So you can see here, I will give the answer because I'm not able to see the responses of the chat. So I will count like single variable. So you will have those number of tables as you have got the variables. Like in this case, age group is a variable, religion is a variable. So you can see in this case, like this age group is one variable, this religion is another. Type of family, and then socioeconomic class. So you will have 4 single tables, and I have joined these 4 tables together to form a single table. So the answer of the first question would be no. There is no software which can generate a table like this, because you have to club tables. The software gives the output and you have to club table. And there are 4 tables in this case. I have clubbed 4 tables, and that's how you are seeing the this table. Now, before we go to the Jamovi, I just want to talk a few minutes about the data and variable. So data, as you all know, but just to refresh the concept, there are 4 levels of measurement. There is a nominal, there is an ordinal, there is an interval, and there is a ratio. So if you go to the nominal, when you change the order, this order does not matter. Like male and female, this is a nominal variable. And it is a categorical variable because it is describing a trait, gender. So this, if you put 2 as a male and 1 as a female, it does not say that 2 is superior or 1 is inferior. So the order or the number here, they are just depicting the trait. The 1 and 2 does not giving you the values in context of 2 higher and 1 lower. But coming to the ordinal scale, which is the, like in this case, you can see there is a ordered level. Like if the pain is mild, and then the second level is moderate, and then third is severe, and you are giving 1 to mild, 2 to moderate, and 3 to severe. You cannot give 3 to mild, okay? Because if you are giving 3 to mild, that means mild has become higher. So in this case, you will label, give the value to a trait or a characteristics which is higher in order, and the number should be high. So that's why severe will go here with a 3 and the mild will go here as a 1. So here the order matters. So that's why it is a ordinal. Coming to the third type is the interval measure. Interval is like when you see the interval between these two time period, like between the 10 a.m. to 11 a.m. and between 8 to 9 p.m., then the both time difference is same, and this is known as the interval measure. And then there is a ratio. So ratio is basically there is an absolute zero. In case of a time, there is no absolute zero, because time for reference we have taken like 12 a.m. at night as a reference time. If you come to ratio, it is like 20, any biological variable like weight, like age. So 20, 21, 22, and 23, and you can see this is absolute zero. So there is a zero age also. Another analogy with this, there are two weighing scale here. So one machine is reading 5 kg and the other is reading 10 kg. So you can see that the difference is 5 kg. Similarly, if there is a time is 10 a.m. and time is 5 a.m., you can see that the difference is 5 hours. But will it be true for the ratios also? So can you say that the 10 kg is twice as 5 kg? So answer will be yes, because there is absolute zero. But can you say that the 10 a.m. is twice the 5 a.m.? No, but answer is not twice, because 10 a.m. is not twice as the 5 a.m. So that's why this is a interval scale and this is a ratio scale, because you can say the ratio as a comparison to absolute zero. So the reference point is actual in case of a first case, which is the weight, where it is the arbitrary in the case of a second case, which is the time. So this is the concept of a nominal, ordinal, interval, and ratio. Interval and ratio scale together, we call it as a scale variable. And then there is a ordinal and nominal. They are read separately. So we'll see in the Jamovi, these are the three options, and you need to give a label to your variable, like how that variable behaves. Is it a nominal, it is an ordinal, or is it a scale variable? So that we'll see. So if you see the hierarchy, then the weakest is the nominal and the strongest is the ratio. So before you start analysis, a few slides on the data management. So this is very important, because data analysis becomes very easy if your entered data is clean and you have managed the data well. So there are three important processes in the data management. First is the data collection plan. So you should have a data collection plan, how you're going to collect data. The variables and the coding of that variable is very important. Second is the data entry, cleaning, and coding. And third is your data analysis plan. So all these three constitutes your data management. So if you want to enjoy your data analysis, you have to ensure the cleanest possible data entry, or if you have not ensured that, then you need to redo it before you start the analysis. We do get many PG thesis for analysis, and it takes around 1 to 2 days. Like maybe I should not say it in the number of days, maybe in the number of hours. So it takes around 4 to 5 hours just to clean the data. There are many missing data, so you need to address all these things before you go with your data entry and the data analysis. So there are some basic rules of a clean data entry. A data entry has got two approaches. Generally, and the most commonly, is the Excel. So we enter the data in the Microsoft Excel or Google Sheet. That is again a good option. And then we import it to the respective software, depending on which software we are using. There are direct way of data entry also, that you can directly enter your data in the SPSS or in Jamovi, but generally we don't recommend that, because many times for one test you have to go for a one type of analysis, and you may need, if you go for a publication, of you, if you're doing a PhD thesis or advanced type of data analysis, then maybe you need a combination of software, like maybe SPSS, Jamovi, or maybe Stata. Few things are good in Stata, few in SPSS. So it's because Excel format is acceptable to all data analytics software. That's why we always recommend to enter the data in the Excel sheet or the Google sheet. So this is a sample data set for entry of a non-coded data. You can see there are only two categorical variable here, like gender and pain status. The others, and the smoking habit also. The others are the continuous data or the scale variable. So like height, weight, and age. So if you enter your data like male and female, or the pain status, which is a ordinal scale here, like mild, moderate, severe, then what problem can you have once you import the data? So in Jamovi, you will not have any problem if you are performing only descriptive. The problem may arise when you want to treat your ordinal variable as a continuous one. Then, because you have not given numbers to these variables, if you want to add and if you want to come up with the total score, like if you are using any Likert scale, and if you want to add the total score at the end, and if you have entered like this, then you cannot add it because it is not a numerical one. So that's why it is better that you give some code to gender, pain status, and smoking habit. Like you can see 1 and 2, male and female for gender, 1, 2, and 3, mild, moderate, severe, and maybe smoking habit 0 for no and 1 for yes. So we recommend a coded entry. In this case, you can see it is like a PHQ-9 questionnaire, and you can see the response is in Likert scale. So undecided, agree, agree somewhat. If you enter like this, and if you want a total score, then you cannot add it. So that's the disadvantage with the non-coded data entry. So we recommend that please enter your data always in a coded manner. Then you can perform advanced analysis. Otherwise, for basic descriptive, it will not have any problem even if you enter a non-coded data. Now, there's another problem which we faced with the students, that is the two-sheet entry on the 2 Excel sheet. So like if your research involves a comparison group, you are doing a case control study or a cross-sectional study with a comparison group, or a cohort with a comparison group, or a randomized control trial. So you have got 2 groups. So now we have got 3 choices. In the first choice, you can see that the person has entered the data in one group A in one Excel sheet and the group B in another Excel sheet. There is one person who has entered in the same Excel sheet, but group A in a and group B in the 2 parts of a same Excel sheet. And the third one is like the person has entered together. So which is the correct option? So I will say the answer here. Correct option is 3. So you need to enter the comparison group also in the same Excel sheet, not as a separate sheet, not as a part of like this here, which you can see. So this is third one. You have to see it together, because then only you can compare and you can perform any test which you want to do. So this is about the basics of the variable. So what we have covered till now. So we have seen what is a descriptive statistics. There are 4 ways to do a descriptive statistics, which is the value frequency table, mean, median, which is the central tendency, and then there's a dispersion. So, and we have seen what is the difference between a descriptive and an inferential statistics. We have also seen how these variables differ, like nominal, ordinal, interval, and ratio. What is the difference between interval and ratio variable, which one has got absolute 0, the other does not have. And then we have seen what are the principles of a data management, how you have to enter, and what are the advantages and disadvantages of a non-coded or a coded data. And if you have got a comparison group, how you should enter that in a particular Excel sheet. And entering the data in Excel sheet is always recommended. So we have reached up till this point. Now, we'll start about the Jamovi, because today webinar is about the Jamovi, but because we thought that we'll give a brief overview, because we were not aware regarding your basic knowledge regarding the descriptive statistics. So now coming to the main session, that is the Jamovi. So Jamovi, it was introduced and released in 2018, and it is continuously updating since then, and it is open source. So people are adding every time, writing module, writing command. So every day it is getting new features. So what you can do with the Jamovi, you can do a basic data analysis with the Jamovi, which we are focusing today and for few more sessions. You can do advanced data analysis also, but that needs module installation, and we'll show you how to do that. And then you can perform meta-analysis also, but that again need module installation. So what are the advantages with Jamovi? So many of you have seen like SPSS. So how this Jamovi is different from SPSS, or maybe it's data, or maybe SAS. So those software are paid one. The first disadvantage or the advantage of Jamovi that it is a free one. So you can install Jamovi and you don't need to use a pirated version like we do for SPSS and Stata. So you can perform analysis in Jamovi, which is a free and available to everyone. Again, in SPSS, initially this Jamovi, the language basically which has been used in creating this Jamovi is the R language or the R software. So most of us know the name of R, but the difficulty which we face as a medico, because R is a command base. Command means you need to write the command. And we are not very comfortable writing the command. So that's why we always like a menu driven. Menu driven means like a drop down menu is there. You only select and press OK and that analysis should be done. So that much we can do because our role is basically is to interpret the data, to perform the command and to interpret the data. And I think Jamovi does this wonderfully, like SPSS. So Jamovi has got both these two options. You can write the commands also. That's why the people are adding module every, with every subsequent, periodically they are adding module and it is getting updated. But again, for people like us, you can go by the menus also. So we only go by the menus. We don't write commands. And the second important thing with this is like in SPSS or any other software, the output is what? It's a separate window which appears for output and your data is in another window. So you need to click the data view and then the output view interchangeably to see the result. But in the case of Jamovi, you will see it is a dynamic. Once you change your menu, the result output will be changed. So you can see all, it saves time actually, because flipping through the output and then again the data view, it takes time. And again, like if you want to, for output also, you have to scroll down a lot to see the result in SPSS. But here in case of Jamovi, you can see very quickly the significance, non-significance, the plain descriptive, the type of table which is appearing. Again, for many, not for the descriptive, but for other part, you will see like for the independent sample t-test or for the inferential statistics, it saves time in formatting table also, because this table, it is in the form of a word and you can copy paste it and then you can format the table there also. But we do recommend that you form dummy tables before you start your data analysis, because dummy tables should be ready. And this is specifically, I'm talking about the thesis and the PhD thesis. So once you have those, even for the paper, small results also, small papers also, if you do this dummy table thing before you start your analysis, you are very much planned what you need to do. So that saves time in formatting. And again, like I have talked that this is in between the R and the SPSS. If you want, you can click the syntax mode where you can see the codes also which are being written here in the Jamovi. And this is basically a point and click interface of the R. So for whom Jamovi is recommended? For if you search in the Google Scholar, you will see that there are many articles which are now, because people always ask us, can we write that we have performed this analysis in Jamovi? Because traditionally we have been writing till now like SPSS or the Strata. But the problem with such type of writing is like, if you do it with the SPSS, again, the license, you have to renew the license every year. It is a paid one. If you use a pirated one, you don't have the full options available with you. You will have got only a limited modules. So those are the disadvantages. But Jamovi, you can always write. Yes, you have performed the data with the Jamovi. And you will see that there are articles which are there using this software as an analytical software. Now we have shared one information with all you people. So that before the start of this webinar, kindly download the Jamovi on your desktop. And this will help because we have shared the same data set to all of you. And you can also perform the analysis simultaneously. I'll go a little slow so that you can learn while you are seeing the webinar, because the direct hands-on we cannot do in webinar, that we will have a separate session as in the form of a workshop. But yes, I'll go slow and you can perform the analysis simultaneously, so that that interface will become very easy for all of you. So we always recommend that kindly. I hope that many of you have installed this 2.2.5 solid version of Jamovi, and then we'll see how to import and how to do the other type of data analysis. So let's learn how to import data, how to compute and transform variable, and how to generate frequency table in Jamovi. So I'll show you first the questions. So first I have to open the given data file in Jamovi, and then I have to label and describe the following variable, because I said that we generally import the data from Excel, and in Excel we have got codes. So you can see the codes here. I have written codes like gender, 1 is for female and 2 is for male. Similarly, socioeconomic status is a 1, 2, and 3. And smoker, diabetes, hypertension, this is 0 and 1, no and yes, similarly. And then there's admitted and non-admitted. Admitted is in the ICU and 2 is in the ward. So this is the exercise which I have to perform. So I'll go click on this Jamovi on my Windows. So since it is installed, so it takes some time. So you can see once it is opening. So I have talked regarding it has got 2 views. So you can see this is the view of your data view, and this is your output view. So in the same view, you are getting the 2 views. Now seeing the other options, what are the options with the Jamovi? So I'll first import the data. So first is to import the data. You can see here the various options, like there is a variable. This is the data. So first I am focusing on this part. If you see the general this is the variable, where you can see variable data analysis edit. In the second tab, you can see here that there are options like exploration, t-test, ANOVA, regression, frequencies, factor, survival, etc. Maybe in your basic one, you may not find the survival and etc. That is the extra thing which you need to install. And then you can see there are 3 icons here. Though this plus is for the module. When you have to download the module or install the module, you use this option. This option is used to increase or decrease the output view. And the 3 dots, can you see 3 dots? So we'll see the functions of these. So now I am focusing on this one, these 3 dots. So this one. So if you click this, you can see that this is a number format. So it gives you like 2 decimal point. Your result will be up to 2 decimal point, or the significant figures you want up till 3, 4, or 5 decimal places it also gives, but by default it is the 2 decimal point. P value also it says that up till what value you want the P value. Then you will see that references. So if I have kept it hidden. If you make it visible, you will see that the reference of this Jamovi will appear in your result. And then if you click on the syntax mode, the command will be written. So let me first import the data. So can you see 3 horizontal lines here? This one. So if you click this, and then you can see there is the option of open. So click open, and then you can see there is the option of browse here. Browse, it will ask you for a specific path, and then I have to browse this demo, import, levels, compute, and transform. This data, this whole folder is shared with you people also. So you can also perform along with me. So I have clicked this, and in data files, you can see if you drop down, see the drop down menu, it has got all the files like Jamovi, CSV, JSON, Open Document, Excel, SPSS, Arts, Data Assess, JASP, all the files are there. So no need to select a specific file and then press open. And then you will see that this data view, it will be populated with the data file, which I have imported. Now here you will see only codes. Gender also you will see 1 and 2. No, male and female is not written here. SES also you can see like 3, 1 and 2. So I need to put the label here. So how to do that? So for that you go to data and there is something known as the setup. So if you click that, it will give you the variable and their description. You can see here, this is for the serial number, the first one. So first one in here, you can see the data type. If you drop down, see the drop down menu, you can see there is an option of nominal, ordinal and continuous. So interval and ratio both is treated as a continuous, and in SPSS, we call it as a scale variable. So these you need to give select a particular type of variable here. So this is a continuous. Again, in data type also, whether it is an integer or decimal or text. So text will be like if you want to enter the name or some symptoms or something like that, then you can use a text, or otherwise we generally use an integer. So data type is an integer. Again, missing values, I'm not talking about missing value at this point. We'll talk it about in another session. And here you can see level. So in this case, it is a continuous, so then there is no level. Again, if you click this, it will go to the next variable. This is the name. So it is just, I don't want name, so I'll go with the next variable, that is the gender. So gender, definitely, this is a nominal. Again, this is not a ordinal variable. An integer is like here, I have given this 1 and 2. So 1 was for female. So I will write 1 as a female. So what I am doing now, I am labeling the variable because my variables are coded. There are no labels here. And 2 was there as a male. I remember I've just shown you the sheet where I have given the coded values of these variables. So 1 was for female and 2 was for male. So if you click this, you can see this gender now, female and male, it has appeared for all the variables. Now this is the age. So again, this is a continuous variable and integer. It has got no levels. Coming to the socioeconomic status, you can see 1, 2, and 3. Again, this is a nominal. You can treat it as an ordinal also, because 3 will be the high socioeconomic status. So maybe I will write low, this 1 as a low, 2 as a middle, and 3 as a high socioeconomic state, and I have chosen it to be an ordinal variable. And you can see like in the socioeconomic, and if you click this button, this will go up and this will appear like this. If you click again this setup, then this appears like this. So likewise, you can go and label other variable like for diabetes. So you can see there are many variables here, and if you come and see if you click this variable view, you can see here that a lot of variables are there here. So diabetes, hypertension, cardiovascular disease, stroke, COPD, all these variables I have to write 0 for absent and 1 for present. So what I can do, I can click this, edit, and then I may select all these variables together, like for hypertension, CVD, stroke, and you can see here in this tab that here all the multiple variables, they are appearing in this case. So you can select this and then you can see that I can create 0. I can write for all these 4 variables, 0 as absent and 1 as present. So this is where if I just go and see the data. So you can see like for all these 4 variables, 3 variables, You can see that absent and present, it is there. Now I'll go again to variable and I'll uncheck this because these are selected now, and then you can see these are there. For COPD also, I could have done the same thing, and for CKD. So this is how you label the this sheet, the labeling of the variable. So now the next section was I have to perform the analysis. So that is the, let me go to the next question. So this was, I have to compute the body mass index. So this is the option which I'll show. So I'll just close this and I'll open another sheet which is there in your data sheet also. So this is the data for the import and the label and the compute. So I have shown you the how to do the importation, how to label the data, and now I will show you how to compute a variable. So it takes some time. Now you can see. Now few options I wanted to show. So can you see this plus sign here? If you click this plus sign here, you can see it takes you to the Jamovi library. So click to the Jamovi library, and there you can see there are a lot of variables. So this installed will show you what all modules I have installed here in Jamovi, and this will show you the available one. So like these are the various options: scatter plot, the structural equation model, the Bayesian model, then the effect size and confidence interval. So you will find a lot of modules are there, and depending upon your requirement, you can download. You can just select it, and if you click this install, it will be installed. But for basic one, you don't need this. Again, I was telling you these three options here, so you can change this output view also depending on your need. And if you click this small button, then this whole view will be enlarged. You will see only the output. And again, if you click this, you can see the data view also. So this I was telling you about the small icon, this arrow, which is here. So if you click this, it will be the whole, this thing will be enlarged. And if you like minimize this, if you again click this, you will have the both options simultaneously. So this one is about the analysis. I will start the analysis now. So the questions, let me see. I have to compute the BMI. So many times you take the variable as such and then you compute a new variable. So in this case, you can see a variable like I have this height and weight also. So in this case, so it has again, same sheet has been, let me go to, so you can see weight and height. So I have to compute a variable. So what I'll do, I'll click here and then I'll press on the, if you go to this data, you can see there is a option of compute. So here, if the variable is compute, okay, so one question is there, ma'am, can you explain how to analyze dietary data? Okay, we may take the questions at the end because then that will hamper the flow of the webinar. So I will explain all the questions in the last 10 minutes. So this is the computed variable. If you have clicked this compute and then double click this, then this computed variable will appear. And this is basically the, maybe I wanted to compute the BMI. So I'll write the BMI here. And then you can write the complete description, that is the body mass index. And then you can see the function. So if a small, can you say small fx here? Sorry. This one. So if you, and you can see a light shade also appearing, like example here it is row 3 and all. On the background it gives you some hint also. So you can take, if you click on this function, there are two boxes which are available here. First is about the functions. So it gives you the various options of functions like exponent, log, log10. We'll use these options maybe in logistic regression. And then there is a statistical options. And then there are logical commands like if not, miss. And then there is a sum, mean, etc. So that command is here. You can use, select these commands. And then there is a selection of variable. So you need to select variable from this box. You cannot, you should not write, because many times we use a small letter in writing variable or a capital letter. So ideally you select the variable from this box. So I need to put a formula for the BMI. So BMI is basically the weight in kg. So what I'll do, this is the weight. So I'll select this. And for selection, you need to double click the variable, then only it will be selected. And then what I'll do, I'll divide this by height in meter square, but height here is in the centimeter. So that square you have to put it in the bracket. So I will again, I'll start the bracket, select the height, then again I'll multiply it, and then again I'll select the height because height is square. Again I'll multiply it to make it in meter. I'll multiply it with the 0.0001. Because there are two height, that's why I need to multiply it with by 0.0001. And once I have written this, and then I'll press enter. So once you write this and press this enter, then you will see that this BMI values, it has appeared everywhere from top to bottom. You can see here that BMI is here. So you can, similarly, you can compute any other variable also. So this is the way we use the option of compute. So in Jamovi, I will again summarize what we have seen. We have seen that this is the data value and this is the output value. The data, how to label the data we have seen. And that is why the option of this setup, we label the data. We have seen the option of compute. And now we'll see the option of transform, how to use a transform. So maybe the age category, I'll show you how to transform, like less than 30, 30 to 40, 40 to 50, and etc. We'll see. And in between, you can see these options. So this is for adding adding a column, and this is a deleting a column. Similarly, this is adding a row, and this is the deleting a row. So these options are also there. So the variable which you want to transform, you may select that variable. So like question, if I see the question is transform the following variables into the age group: less than 30, 30 to 60, and more than 60. So I have to make these three categories. I'll go with to the Jamovi because I need to transform the age category. So you can do two things. Either you can click this age, right click, and then you can see there is option of transform, or you can go from here also transform. Here it directly takes this age, and here I can write the age category. And then from this selected variable is age. That means it is transforming age. This is, I have to click the new, create new transform. So I'll click this create new transform. And this again, new transform is for the age category. So I have given a name to it. Again, I have to give the recode conditions. So I have clicked this add recode condition. And then you can see here, there's a small if here. So if you click this if here, let me wear my specs. Yes, so this is there is a small operator. You can see here. This is a double equal to sign. So double equal to sign appears in the Jamovi for equal to, then this is for more than, this is for less than, this is not equal to, and this is greater than or equal to. And if you go down, this is less than equal to. So this is like less than 30. So what I'll select? I'll select less than 30. So I have to use here, and here you have to write a single quote. Whenever you are writing it in the form of a words or letter, you have to give a single quote. You can see here in the background, it is writing male and then in the single quote. So I will use here less than 30 years. But again, I have not used a single quote. So I will use a single quote here, both the side, or single inverted comma. And then this is 1 year. So you can see that less than 30 year, it has appeared here. Again, I need to give a second condition, that is between 30 to 60. So 30 I have written, so it will take 30 automatically. Next, I have to take the 60. So less than equal to 60. So I will use 30 to 60 years. And here again, I have to put it in the form of a single quote. And then, okay, then you can know something. Okay, so what I have done some error. This formula is misspecified because I have not written here 60. So what I'll do, I'll again cut this and I will again use a add recode condition. And whenever there is some mistake, you always redo it. So I will write here less than 60. Or you can write, if I'm writing 30 to 60, then you can write less than equal to 60. But again, you need to delete this command. And here you can write in the single 30 to 60 again in this single, and then you can see 30 to 60. Else use more than 60. So more than 60 in the single quote. And if you click this, so you can see here that it has populated all these age category. And once you transform or compute any variable, a dot appears next to this variable. So can you see a dot here? A small dot here. This dot is not here in the socioeconomic status or in the diabetes or any other variable, original variable. Since we have transformed this variable has got a dot sign. So I'll again show this. You have to go to this transform. You can select this variable, right click this, and then you can see how this is being categorized. And then you can put this conditions, like if I double click this, so you can see I have used this age category. So you can go and you can click on edit and you can see what I have used. So in this case, you need to select like less than or more than, and here you have to give the label. So label in this case, you cannot write separately. Label you have to do it simultaneously, because the way you have labeled the socioeconomic status and diabetes, that option will not appear here. So you have to do it again here. Now again, someone is asking me to repeat the import. So import again, these three horizontal lines are there. Click this, click open, show the path, and then you select the file type. Once you browse this, it will lead to a specific file type and you can import that Excel. So this is how we import it. I will recommend to all of you that for the next webinar, please do come prepared with the installed Jamovi. We may go a little slow, but you perform the actions simultaneously so that you will learn more. So this was regarding so I will just summarize what we have done till now. So we have seen how to import the data, how to label the variable, how to compute, transform, and then add and delete. These options we have seen till now. So the questions I have discovered. Now going to continuing. So now have you understood the concept of this frequency table, the counts, and then the computation and the transformation? So going back to the descriptive. So we have seen this. Now, we will discuss about the central tendency and the dispersion. So there are measures of central tendency, and you can see that we have got mean, we have got median, and we have got the mode. So mean we use when there is a normal distribution. Median we use when there's a skewed distribution, and mode we use when which is the greatest frequency. Like in this case, you can see there's a data set. So it is a data set of 10 individual. How will we calculate the mean? We'll take the sum of all value and we'll divide it by 10. If you have to see the mode, which is the most frequent occurring, this is the 220. So 220 appeared twice. That's why we'll take the mode as 220. And this is the, if you have to calculate the median. So in this case, if it is the even. So for the even, you take the sum of the middle two values. So median is 200 here. Similarly, about the distribution, it is a normal distribution. In case of a normal distribution, the mean, median, and mode coincide. I hope you all know all these things. Just to refresh it, I'm telling it. And mean is the most sensitive measure because it is very sensitive for the extreme values. That's why for extreme values, we always say that you should go for the median. And for normal distribution, you can use both mean and median. But for a skewed, you should preferably use the median because mean is not the true measure. It is dragged in the direction of the skew. But the median is not affected by the extreme values. That's why we use median in case of a skewed distribution. Now coming to the measure of central tendency, in what type of data you should use what type of central tendency. So for a nominal, we use the mode, which is the frequency. For ordinal, we use the median. For interval and ratio, which is not skewed, we use the mean. And for interval and ratio, which is skewed, which we use the median. Coming to the measures of spread, which is the dispersion, you have got a range, which is the highest minus lowest. Then you have got a standard deviation and variance for a population. And you have got a standard deviation and variance for a sample. For example, in this case, you can see that the variance is what? It is the sum of square divided by total sample minus 1. And how we calculate this? You have got a individual mean and you have got a group mean. So you deduct this group mean from an individual mean, you square it and you add it. That is known as the sum of square. We learn more about these in the ANOVA. And this is the variance and the standard deviation is the under root of this. Standard error is the, if you divide the standard deviation by under root n, it is the standard error. So now how to do an overall descriptive table, that is the median and mean. So in this case, you can see that this is one way of representing the mean and median. So here the anthropometry, the BMI, mid upper arm circumference, the median and IQR is given. And in this case also, this is one article in the BMC Nutrition. You can see that the author has given the mean along with the 95% confidence interval and median along with the interquartile range. This is again one article where we have seen that was a cross tab, and you can see that we have seen, I think, initially also this one. The author has given both the frequency table and the mean in one table. Here the age and BMI, you can see it has been given in the same table. So the author has clubbed these two tables. So before you select what type of central tendency you should use, it is important for you to check the normality of the data. So how to do that? So basically, like if you have measured the blood pressure or the SGOT of 5%, and then you have to decide whether you should use mean or median, you have to describe your data. So there are two values here. You can see the SBP, the individual values are ranging from 110, 8, 20, 22, and 100. And the other is the 10, 110, 8, 210, and 12. So with the raw data, can you say like where the variability is more? So definitely you're very right that variability is more in the case of a SGOT, because here they are highly dispersed, like 10 is also there and 210 is also there. So for such type of data where the values are more dispersed, you should use the median that we have seen. Now the values in a continuous data set, you have got a normal distribution or you may have a skewed distribution. So for a normal distribution, we use the mean and standard deviation. For a skewed distribution, we use the median and interquartile range. A normal distribution, most of the observations, they cluster around the central peak and the values lie farther away. So that's how the bell-shaped curve is formed, because it is naturally like that. So there are both subjective and objective ways to know about the distribution of the data. There are two ways to test for this normality. If you go with the numerical method, that is an objective way. It is an objective judgment, but that is sensitive for a very low sample size, like 50. If your sample size is less than 50, then you can go with the objective measurement. And the objective measurement are the skewness, kurtosis, and Shapiro-Wilk. If you go for the subjective judgment, and subjective is the graphical method is the subjective, and where the QQ plot and the histogram, they are most commonly used. And in this case, you need to have a little bit of experience to visualize the graph. Whereas in objective one, it's clear cut. But again, if your sample size is more than 50, then this Shapiro will give you a false value. So that's why you should not go for a Shapiro-Wilk if your data, number of data is more than 50. You can see here that distribution, both are normally distributed. In this case, one is skewed and the one is normal. Coming to Shapiro-Wilk test. So Shapiro-Wilk test is null hypothesis says that the data is normally distributed. That's why if the value of a p-value of a Shapiro-Wilk is more than 0.05, you say that the data is normally distributed. So here you want p-value to be more than 0.05. Generally what we always desire us to have a p-value with a less than 0.05. But in case of a checking the normality, we always want our p-value to be more than 0.05, because that will say that my data is normally distributed. But again, I said that it is suitable for a sample size less than 50. Coming to skewness, it measures the symmetry of the curve and it measures with the direction of the tail. Then there are right and left skew. And for normal distribution, it should be within 2, whether it is a plus or minus. Plus means it is a right skew and minus means it is in the left skew. Kurtosis means the pickedness, the height of the graph. So more pickedness of the curve, more kurtosis. So we call it as a, if there is a leptokurtic, we call it leptokurtic. If there is a more peak, if there is a less peak, we call it as a platykurtic. And again, like this thing, its value should also be within plus minus 2. So this is skewness and this is kurtosis. Then again, subjective way, these are the histogram. You can see it is more like a bell shape. And for QQ plot, it is one of the best method for assessment of normality graphically. But again, likewise, I said that you need to have a little bit of experience to visualize this QQ plot. If the data is normally distributed, the circular dots, we'll see that will be along the diagonal line. That means it is a normally distributed data. So normal QQ plot will appear like this. You can see that this is the one line, and here you can see that all the points are along this diagonal line. Here also you can see that all the points are along this diagonal line. So it is the normal distribution. Now, how to check outlier in case of a QQ, in case of a data? So it is done by plotting the box plot. Now, what is a box plot? Basically, you see it is also known as the box and whisker plot. So there is a box in the middle. The line, the thick line, that represents the median. It is not the mean, that represents the median. The two edge of the box, they are the interquartile range. So this is the Q1, which is the 25th percentile, and this is the 75th percentile. Now, how to decide for an outlier? So outlier is decided by any data point which is outside this minimum. So this minimum, how we define minimum? This Q1 minus 1.5 times this interquartile range, or the width of the plot, is the minimum. Similarly, this Q3 plus 1.5 times this interquartile range is the maximum. So you can have a minimum or a maximum outlier, and any data point which is outside this are known as the outlier. So you need to report the outlier. So this is for the box plot. So now let's learn how to check the normality of a continuous data, how to make a descriptive table overall, and how to make a across table descriptive. So I'll again go to the Jamovi. Here we can see I will have to open another data set. So probably I'll import here. So I'll go to this open, browse, and then this is for the frequency. So I will open this. So I have not shown you the frequency table also till now. So frequency, if you go to this, I've shown you all the other options. You go to this exploration. You can see in the analyze option, there is an option of exploration. If you click this descriptive, you can see there are two windows. So first I'll show you with the plain descriptive. So even if you have not done anything, these table will appear automatically. So in statistics, you need to uncheck this. So what I'll do here, you can see I will perform actions here and the result will appear on the right hand side. So I have unchecked this because I just want to show you the frequency table. So I have unchecked this and now you can see. So for frequency, what I'll only enter the categorical variable. So like I have entered all these diabetes, stroke, and you can see total number of comorbidities probably. So all these frequency will start appearing. It will take, you can see the buffering appearing here, and it will give you the, and this, since I have not clicked the frequency. So can you see here, there is a box here in the frequency here. And it also shows you what type of variable you can enter. So this flower sign is for the nominal, and this stacked bar is for the ordinal. So I need to click this. So what I'll do, I'll click this frequency table, and then you can see that the frequency table starts appearing. So you can see that it will give you the gender, the frequency of socioeconomic status, the diabetes, the hypertension, etc., percentage, and then cumulative percentage. And similarly, so remember we have asked a question in the beginning. So for each variable, there will be a separate table, and you need to club all these tables together to form a total table. So this is for the frequency. If you want to know these frequency across a category, probably a gender, then what I'll do, I'll put this gender in this split, and then you can have a cross table where you will see that it will give you the gender wise, like male and female, and then the count, like no hypertension as well as hypertensive. Similarly, you can see total number of comorbidities. So it gives you the yes. So now it is visible. There is some time lag between my showing and appearing on the screen. So now you can see that this is the cross tab of the gender with the other variable. And if you want a box plot, in this case for frequency, you can see here an option of plot. So here you can see there is an option of plot. So if you click this plot, and if you come down here, you can see there is an option of bar plot. So not box plot, bar plot. So if you click this bar plot, the bar diagram will appear both for, because it is a cross tab. I have done it across gender. So that bar diagram will appear. Again, it takes some time to appear. So till the time I will show you the other options which are there. So you can see the options of central tendency. So mean, median, and mode, sum, and there. Then there is a dispersion, standard deviation, variance. You can see there are various options. I'll just focus on these one by one. These are the options of central tendency. This is the option of distribution, which we have talked, skewness and kurtosis. This is for the normality, Shapiro-Wilk, which I have told you. This is for the dispersion. And this is for the percentile, the location, where we have read that either you can have a cutoff point or you can click on this 25, 75, 95, 75 or 50. Or if you want like 50th and 95th percentile, that also you can plot. So these are the options for the descriptive. And for the frequency, we have seen. So if you want the descriptive, I will uncheck this. So let's see the questions on descriptive. Again, before we move to that descriptive, you can see the bar plot. This bar plot has appeared here. And how you can but again, you can see that once I have unchecked this frequency, that whole table, it got disappeared. Hello, mic check.
Yes, ma'am, you're audible.
Okay, thank you. There was some network issue at our end. We are extremely sorry for that.
Oh, no issues, ma'am, no issues. So you can carry on.
Okay, thank you. So I was telling you how to
Ma'am, but you're not visible. I
I'm
think your
not
camera is not working.
Okay, let me. Okay, I think because of the connectivity, we have switched off the camera because then I think there will be more problems. So it is in the switched off mode.
Okay, ma'am, then you can press it.
Okay, so I hope I'm audible to all of you, and thank you. Again, we are back. So we were discussing regarding how to copy the result. So you can see here that once you put this in the command, if you double click this, this window will appear. So you can, if you want to copy, because if you like move this back to this window, then this will disappear because this is a dynamic output. That's what we talk. So if you want to preserve your, keep your result, then what you can do, you can right click on this window, and then you can see here there is a something known as the all. You can select all, and then you can go and copy it on a Microsoft Word. So this is my question, but again I'll show you. You can, if you copy paste, then all your result and graph that appears here, which you have kept. So you can see these graphs and the tables also, this will appear, and you can edit these tables here, or you can make a separate dummy table because you need to club the tables also. So this is we always recommend that you copy the tables and result on a separate Word format, because once you move this, like now I have to do a descriptive statistics. So I will move all these back to here, or what you can do, you can duplicate the result. So what I can do here, I will go select, and then you can see there is an option of duplicate. If I click this duplicate, the new, that upper one will be saved, and then there will be start of a new output. So now if I move these variable back to this window, then you can see that this will disappear, but the upper one, it will be there with you. So that you can do, you can duplicate the result. And then again, now I have to show you the mean, median, and mode. So before we do that, we need to check for the normality of the data. So there are continuous variables. So like age is a continuous variable. Again, if you go this systolic blood pressure, BMI, I will uncheck this bar plot because unnecessary it will keep on appearing. And I'll uncheck this frequency table also because I want now for the normality. So BMI, then systolic blood pressure, I'll show you with a few variables. So since sample size in this case, you can see it is 180. So which test I should be using for the checking normality? So basically we'll be using the QQ plot, because although Shapiro-Wilk is there and the skewness kurtosis is also there, but we will not use these tests because our sample size is more than 50. So I'll go with this QQ plot and the histogram, and then you can see the QQ plot and histogram of all these variables. So again, it takes some time. This you can say AC age, the histogram, and this is the QQ plot. So you can say what we discussed, that the individual values will be across this diagonal line. So if it is across the diagonal line, then we can say that this is normally distributed. Again, if you click this density plot in the histogram, you can see that this bell-shaped curve that has this is appeared. So this you can see that this is normal. For the other also, this BMI is also appears to be normal. You can see here QQ plot also shows that it is normal. So you can perform more than one type of plot to check for normality, and you can say like which is a normal distribution and which is not a normally distributed data. Again, if you like, I have checked for this, and now I will go with the checking. So let's see what are the questions here in the so you can see I had to show you the gender-wise distribution that we have seen, the age-wise distribution of patients. And then you can see this is the dummy table and all the tables like male, female, then category of the age, interpretation also you can write in the Jamovi also or here also, and frequency table across the gender. So this you can see age-wise distribution. This is the cross tab. Now coming to the normality testing. So I had to show you the BMI, cortisol, ferritin, and LDH, the four types. This is the QQ plot of all the four, and then you can write that whether they are normally distributed or not normally distributed. Again, I'll show you the LDH, and because that is not normally distributed, so you need to have a look at that also. So if I go with the cortisol, move this, and then the ferritin also, and LDH also. So if you go down and see the graph of those three, you can see that this is clear cut that this is not normally distributed because this is not across the diagonal line. Again, this also you can see that this is the LDH. So LDH is also not normally distributed. So actually this data set is for the COVID patients who got admitted at AIIMS, and we have selected 170 patients. And these are the variables of those patients. Now, if I check for the variables, and then you can see the standard deviation, and you can see the variance, and you can see the interquartile range also because your median is also there, but that this table will appear on the first place. So you can see here there is a table, this one. This is one table where all the mean, median, standard deviation. So am I audible now?
Yes, ma'am, you're audible. Kindly share
Hello?
your screen. Yes, ma'am, am I audible to you?
Yes, you are.
Okay. Ma'am, kindly share your screen.
So is my screen visible?
Yes, ma'am, your screen is visible. Kindly go on.
Okay, so I was just regarding these options like box plot, and you can see here the box plot I was telling you regarding these data points. So you need to report it like this serial number 106 and then 53, 4, 131. But again, this option is different from this. If you click this outlier, you will have a table of most extreme outlier, like highest and lowest. So these are only the extreme values, but outlier generally we designate on the basis of the box plot. So you can report both these values like box plot value and the extreme outlier values in your descriptive statistics. So this sums up with all the descriptive statistics. So I have told you all the options. Let's summarize. Again, against this split, if you want to have this against a category, then again you can go keep gender here, and then you will see that all these mean and the median and all the graph, you will get it across the gender. So we have used these all options, and since I think data is not stable, so we need to So you can see here that this gives you like male and female, gender-wise, like BMI score, systolic blood pressure. You need to reframe this table because you cannot copy paste this table and produce it as such. So that you need to do that much exercise. And again, I was telling you that you can write the description here also. So if you like type it here, although you can write it here and then you can import it. So I think we are ending this webinar, few questions which we could not answer. And but we will be back with you people. This is
Ma'am, we cannot hear you properly. Voice is breaking.
India.org. You can download it from the website. And these are